in every subsequent iteration of this process, the same thing will be true. And the distances between them will get smaller and smaller and smaller. But there will always be the same story to be told about the next iteration. Isn't all that true? Can't do it. Can't do it. I mean, I can't get to this book, you see, because first I have to go half the distance. And then I have to go half that distance. And I have to go, this is another one, half that distance. And, that's an infinite process, and people can't do it. Just get the book you want to see, right? Just grab that book, catch that tortoise, or that hare. I mean, I understand, I'm not disagreeing with you in substance, but he wants to know, his thing is not, you can't have an argument that's different from that. It's, what's wrong with this argument? No, he can't catch up to it. He can get to that. Since he's moving. Well, actually, this is a problem. Zeno's one way of understanding Zeno and the whole Parmenidean effort is to show, to produce some sort of proof that the whole idea of motion is incoherent, that it leads to paradoxes. And that's one way of interpreting it. That's actually maybe a little bit. If that's the way to understand Zeno, then he'd say, well, all right, you can produce an argument that shows that Achilles can pass the tortoise. I can produce an argument that shows that Achilles can't pass the tortoise. And unless you see something wrong in my reasoning, some detail of my reasoning is incorrect, this shows that our whole understanding of motion is incoherent. There's an incoherence here. Let me go in the back. We're going to wind up dwelling too much on Zeno, but he is interesting, so let's do a little longer.
So what he's saying is Achilles starts behind the tortoise is up here, the tortoise loops on the Achilles.
No, first, all right, well, they start up here, bang, all right, race, but you're right, tortoise is spotted a certain distance. So bang, the race is on, now, we know that Achilles is going to get up to that position. But by the time he gets there, the tortoise will have moved beyond. Right? Okay. And then there's another hand. Yeah. Certainly wasn't. Well, that's a problem in its own right, though. About the limit, as in Newtonian physics and as in calculus. That's a problem for some of the same, more or less intuitive, like I should say, commonsensical reasons. And maybe you understand the limit in a way that's crystal clear to you, but I think if you were to talk to Zeno about it, so we had Newton and Zeno together, I think Zeno's approach might be something like this. So, all right, now, tell me again about the idea of the infinitesimal. Because this is a discussion about continuity and things like that. Now, what is the infinitesimal? What is the size of this thing? Oh, it has no sign. But you put a bunch of these together and it gets to make a line? Well, not exactly. How about instantaneous velocity? What is that again? Well, that's distance elapsed from unit time where both are reduced to not zero. You can't divide by zero, but to the limit. Right? Well, what is that again? Well, it's when there's when there's effectively no time. Well, if there's no time, then no distance is elapsed. Well, right, but it's hard to make a physical interpretation of either the infinitesimal or to make an interpretation of any of the things and concepts that are used with such brilliant effect in the calculus and its interpretation of physics. There are some kind of counterintuitive problems there. It's hard to make what you might call philosophical sense. It's hard to make sense out of these conceptions, even though when used, they produce good results. And when Newton produced the calculus, and another fellow Leibniz produced it as well, independently about the same time, there were problems in explaining the cognitive significance of some of these mathematical entities. Here's a comparable one in contemporary physics. When we talk about the Big Bang Theory. And yet, if I'm not wrong about this, the Big Bang really can't be interpreted in the way that it usually is in the popular press by those of us who aren't physicists. It cannot be interpreted as an event in time, because it's neither in time nor it's not in any place, and it's not at a time. Because it's not just matter energy that supposedly is produced in the Big Bang, but time-space itself. Space-time itself is part of what's produced in the Big Bang. So it is not itself a moment in time or in space. Now, that doesn't mean that the concept is to be thrown out. It means that we don't have a clear cognitive grasp of that concept. And I think at the very least, what Zeno is trying to argue as regards motion is that there are very serious cognitive problems in understanding motion, and they can be exposed through the use of paradoxes. Back to you first. We're just using mathematics. Well, the hope would be, especially for these guys back here, the hope would be that your tools would themselves not need this more explanation than the thing you're trying to explain. Like if you finally say, well, I'm going to explain motion on the basis of the infinitesimal, I mean, their reaction might be, what? I mean, motion isn't that. I mean, motion is difficult enough, and now you're going to bring in this more difficult thing to explain, and that doesn't really explain it. What it does do is it assists calculation. That's what the mathematical truth plainly does. I don't think anyone would deny that. But when you ask yourself this, I mean, there's millions of philosophical questions you can ask about math and its applications and about science. But one of the things that you might ask is, well, what's going on here when I'm using the infinitesimal? What is the infinitesimal? There are now philosophers of mathematics, and they are all of them state-of-the-art mathematicians themselves. These are not just people who sit on the side. But there are people among mathematicians who take this position, that the whole idea of infinity and the infinitesimal is, in the end, a bad idea. Just because it is so unwieldy. And if they could, I don't think they can, but if they could found mathematics on a basis that didn't require the notion of infinity, they'd be very, very happy, because it's not a very clear notion. But if you figure, once again, if you go back and think that philosophy, one, is the domain of answers, of problems that don't have very clear-cut answers, and if then, as a corollary, you understand the philosophical effort to be trying to give clear answers to those questions, then you can see why something like the notion of the infinitesimal wouldn't be, wouldn't immediately lend itself to that kind of interest. You're trying to get clarity here, and the infinitesimal really gives a major benefit. But at least, especially for somebody like Zeno, he would want to know, well, how can we understand the line as being divided into an infinite number of infinitesimals? I mean, how does something get from one of those infinitesimals to the next? So, well, really, it's a continuity. Well, it's not divisible. Is it? It's a number of infinitesimals. Is it atomized, or is it a continuity? And those are interesting philosophical questions about the line, the racetrack along the line. But Protagoras this is going to be a key element later on. It's not important to the apology, but when we get to the Meno, I'll want to refer to not only Protagoras' claim that man is the measure of all things, which is a very plausible one, but to another contrary claim that arose right around the same time by a group of people called the Pythagoreans. Now, I'm going to put Pythagoreans, a group name, rather than a single individual's name, because while there is an individual here, his name is Pythagoras, nevertheless, this is a kind of almost a religious cult.
Nevertheless.
And it's not entirely clear which person associated with that cult is responsible for which of the things that we know came out of it. What is the most well-known product of the Pythagoreans? Oops. Pythagorean theorem. Which says what? Yes, that's what they all say when I ask them that. I'll put this way, c squared equals a squared plus b squared. That is the modern way to formulate the Pythagorean theorem. But to formulate it in this way requires the work of a much later philosopher mathematician named Descartes, who we'll get to later in another connection. But Descartes is pretty much the inventor of a mathematical technique which allows you to express geometric truths in algebraic form. When you see things with these letters, c squared equals formulas like this, that's called algebraic form. But the Greeks, of course, didn't have what is coming called analytic geometry. They couldn't express the truth that way. So what they did, that's true, that is the modern expression of the Pythagorean theorem, but what they learned is that for every right triangle, there's the right angle. And the hypotenuse is the name they gave to the side of the triangle opposite the right angle. For every right angle, not the most accurate of drawings, for every right angle, the square on the hypotenuse, see that square, is equal to the sum of the squares on the other two sides. And what that means, geometrically, is that the area of this square, call it C, is equal to the area of this square plus the area of this square. Now, I'm just calling those things. And if you look at it, it comes to the same thing, because the area of this is going to be equal to this multiplied by itself, this line, and similarly for the other two squares. But the way they had this, to prove this was by geometric constructive methods. They had to show that if you plot this square over here, blah, 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 then you get this, and then that line. I mean, they had to, by geometric methods, show through various comparisons of figures and flopping these things around. You'll see some of that done in the Meno.
Well,
but they had to prove it by
I guess I'll record more videos later
They
on.
were indeed able to prove that for all right triangles, the square on the hypotenuse would equal to 70.
Here's the map that I was looking at for the
They
gang
also learned
attacks.
such things as that when musical